you're like me, you might occasionally have trouble finding things, like your car keys, socks, your reading glasses. Fortunately, through computational thinking, we can create simple algorithms to help improve our productivity and efficiency with searching and sorting. Imagine a library with all the books in random places, children's books mixed up with science books, history books mixed up with maths books. One book might be written by an author with the surname that starts with S, and the book next to it is written by an author with the surname that starts with an A. It would be very, very difficult to find the book that you wanted. Luckily for us, libraries adopted the Dewey Decimal System, which sorts books by numbers using codes specified for each subject area, and then alphabetically by surname of the author. This lets you type the name of a book or its author into a computer search box. The computer will then use its search algorithm to find a list of books with their Dewey number, and you can take this number and find the exact location of the book in a library. Have you ever wondered how things appear in a particular order, like the songs you've downloaded onto your phone or the names in your contact list? The answer is that digital systems use special sorting algorithms to put the items in the correct order. Let's see how some of these work. Here's a list of some of my closest friends from my contacts list on my mobile phone. At the moment, these names are in no particular order, which isn't very helpful when I want to call someone. So how could an algorithm sort them into alphabetical order? Let's take a look at one way that an algorithm could sort out my contacts list. We start by looking at the first pair of names, Anna and Oliver. Anna comes before Oliver in the alphabet, so they're already in the right order and there's no need to swap them over. We then look at the next pair, Oliver and John. These are in the wrong order, so we need to swap them over. Now we can look at the next pair, which is Oliver and Barbara. Again, they're in the wrong order, so we swap them over. You can see that once we've been through the list once, the name at the end, Victoria, is in its correct place, but there's still plenty of sorting to be done. Since there are 12 names, we'll need to go through the list 11 times to make sure that it's fully sorted. This algorithm is called a bubble sort, since the names at the end of the list bubble up through it each time we make our comparisons. But bubble sorts are quite slow. This doesn't matter if it's a short list, but if you were sorting a much bigger data set, then using this algorithm would be very, very slow to solve the problem. Let's look at a faster way of doing it. Here's our original unsorted list of names again. This time we'll start in exactly the same way by comparing just the first two names, which don't need sorting. Then we'll do something different by taking the third name and putting it into the correct order among the names we've already sorted. In this example, it means comparing John with Oliver. Since John should come before Oliver, we swap these two names over. So far, this looks the same as our bubble sort. Here's where it gets interesting. We take the next name in the list, Barbara, and do the same thing. Compare it with the name before. Swap if necessary, and keep doing this until the name is in the correct place. See how Barbara moves all the way along to the correct place in the list? This type of sort is called an insertion sort because we take each name in turn and insert it into the correct position from the beginning of the list of names. Let's look at one more approach to sorting, which is known as the quick sort. Actually, that's just what it's called, but it's not always the quickest way of sorting. There are many sorting algorithms, and which one is best depends on what type of data you're sorting and how you want to sort it. However, it's quite commonly used, and again, it's quite simple to understand. Let's have a look. First, pick a random name. Just as an example, let's pick one more or less in the middle. So we'll start with Kim. We then go through the list of names and compare each one with Kim. If the name comes before Kim in the alphabet, then we put it in one group, and if it comes after, we put it in another group, like this. Once we've done this, we don't need to compare any of the names before Kim with any of the names after her. Now we take one of the groups and do the same thing. We might look at the second group and pick Rich, then put the other names before and after as we did before. We would end up with this. When the groups get small, they can each be sorted using one of the other sorting algorithms we've already looked at. Before we finish, have you wondered how it's possible for a computer to know that A comes before B in the alphabet? Well, It's all down to those binary numbers again. Remember how we showed you the UTF-8 character representation table in Workshop 2? When a computer sorts text, it compares the UTF-8 values to see which letter should come first. Now, you've seen how different algorithms can be used to sort data. Sorting data first can make searching a whole lot easier.